Okay, cool. So I'm going to be talking about how real developers test in production. If you see the bang there, not really. We don't test in production. You could. After I'm done today, you could, but I still tell you not to. So my name is Isha. I'm a developer. I work with Mavericks Consulting as a senior consultant. I've been a developer for almost 8 years now. And most of my work was in offshore delivery, but I've been a full-time consultant for the last 2 years now. And I'm learning a lot of new things after moving to Singapore. And the one thing work-wise that I've learned is developers are really scared to make changes in systems they don't know. So hopefully I will talk about a few things that may help you in case you're somebody who works with new systems all the time. And yeah, let's just jump right in. So before I talk about what I'm going to actually talk about, let's just get a few terms out of the way just so we're all on the same page. It's actually very unnerving to see a big room with so many sporadic people. Okay, but thank you all for coming. So let's first talk about branching. If you've used version control systems, you should be familiar or might be familiar with the term branching. Normally when you say branching, people think of Git branches, which is not entirely wrong, but it's not strictly a Git term. Branching in revision control and software configuration management is duplication of an object under revision control, such as a source code file or a directory tree, so that modifications can happen in parallel along both or even multiple branches. So when you do a Git branch something, you create a parallel branch of your master or your trunk, and then you can make changes, merge them back, do whatever you want with them. There are several development strategies that are associated with branching specifically. So if you've heard of, there's feature branching, there's release branching, there's story branching, and there's a whole load of other things. I almost swore I should remember not to do that. The other one is pipelines. If you have used Jenkins before, you might be familiar with the concept of pipelines. A CI/CD pipeline helps you automate steps in software delivery process, such as initiating code builds, running automated tests, and deploying to a staging or production environment. I lifted that from the Semaphore CI blog. Since I spoke of Jenkins, this might be familiar to some of you. You have different stages. They may be green or red, depending on whether they pass or fail. And you can do your continuous integration by building, running tests, doing all of that, and also deploying. In this case, it's deploying to production directly, which I would be very scared to do, but hey, to each their own, right? The last term is environments. So an environment is nothing but a running instance of your application or your software that you can use for any purpose. So to quote the definition, in software development, in software deployment, an environment is a computer system in which a computer program or software component is deployed and executed. If you're familiar with the software delivery lifecycle, you have different test environments and you have a production environment, which, as the name suggests, are used for different purposes. Cool. So with that out of the way, let me tell you a little bit of a story. A few years ago, I was working with a client which was a multinational B2B retailer in Europe. B2B is business to business. So what they used to do was provide things like groceries and wet and dry goods to restaurants, hotels, the little kiosks that you have at the train station, that sort of thing. And I was working specifically with their order entry and fulfillment platform on the transportation management and route optimization team. So we had this huge platform which was used mostly by their sales folks to go to the clients, get their data, get their address and everything in there, what kind of business they run, what kind of requirements they have. Then later on they would the clients would place orders on that platform. And then there was a whole flow there. There was order entry, there was order management, there was pick and pack, which was essentially the packaging of goods from the warehouse into actual something that could be transported. Then there was transport management. And then there were a whole bunch of other things after that, such as returns and refunds and all of that. Our architecture at a very simplistic level looked something like this. There were multiple verticals. Each vertical had multiple services, and all of those connected to the same database. This was a Cassandra database that we were using. One problem that is very obvious here is the fact that services are shared across verticals. Which means that given that there were different teams working across different verticals and not all of them from the same vendor, so because this was a client, there were different vendors associated with them, And because there were different verticals, there were different teams, there were different styles of working from each team. So what it ended up being is that we were constantly stepping on each other's toes. Somebody pushed something that broke something else. Oh, but my changes are not in there because somebody overrode it. All sorts of things happened. And there was, of course, the fact that there was just one database also meant that sometimes we might end up duplicating things that multiple teams need. So a few things that were also problematic there were that we had only a single pipeline per service, so which means that we didn't have the option of deploying different branches in a test environment and different branches in production, or even different branches across different test environments. It had to be the same branch being deployed across multiple environments, and that's something that we did not have control over because, as is, from what I've realized, more common than I initially thought, that the DevOps team is a completely separate little bubble over there, which no one really knows about. You just raise requests and they may or may not do what you ask them to do. So this was a problem. Okay, I'm glad Michael finds that funny. So there was a problem that we didn't have much control over the pipelines and the deployments that we had. We also didn't have versioning across services. So let's say if a new version of a different downstream service got deployed and that broke something, that immediately meant that we were blocked from using it any further, because we couldn't just use a different version unless they fixed what they had. And last but not the least is our development strategy looked something like this, where we were using a tool called Gerrit. I strongly recommend not to use it. It's not the most sophisticated tool out there. So what Gerrit would do is, we had a master branch. Every time you committed to a branch, Gerrit would create a new branch for that commit, run a whole bunch of tests on it. There was a Jenkins integration. It would run those tests, and then once the build was green and you had at least 2 people review your commit, it would then go back and be merged to master. Now, in itself, this is not really problematic if you're sticking to having smaller commits, you're making sure everything's in place and running everything locally, testing everything locally. But the problem there is that given everything was going back to master as is, it meant that we ended up having very long running commits. There were huge commits going in one go because people don't want to break master. Some pain points that all of this led to, like I said, there were large commits which led to a lot of merge conflicts and duplicated implementations. So if people in 2 different teams, 2 different verticals which are working on a shared service end up implementing something that is similar, there is no way for them to know that this is something that could potentially be reused unless the code went into master. And at that point, it's a little too late, because then you're like, oh, then you refactor, then you rewrite the implementation, then you do this, and then you do that, and it gets very complicated. So there's a lot of rework involved. The other was that work in progress code could be accidentally deployed. So if I'm not very careful about my commit and making sure that everything's green, everything's passing, and I'm not checking in something that's half-baked, until I'm very confident about that, there is a possibility that work in progress things might get deployed, and then again that ends up breaking master. The other thing that was being followed from even before I joined the project, or we even came in, was that people were reverting and re-reverting changes every time they needed to commit. So now, because everything was going to master, now if you wanted to deploy something that was 12 commits earlier, then you first revert the 12 commits, then push and then re-revert those 12 commits to make sure you could deploy to a test environment. So this again constantly led to a lot of work for the developers in the first place to have to do this all the time. And like I mentioned earlier, because there are interdependent services and the lack of versioning and the fact that there is a lot of dependencies, it all led to a lot of complications, and it led to merge conflicts, it led to verticals not knowing what the other teams were doing, and because the services were interdependent, I've said it a few times already, we stepped on each other's toes a lot. So in order to now get rid of all of these pain points, we had to find a solution to fix it. Just to get a sense of the room, how many people here work with feature branching or story branching? Oh, almost everyone. Interesting. Okay. Just do you find it works for you perfectly? Are there anything that you would change about feature branching? No? Oh, that's interesting. Okay, cool. Maybe I'll change your mind. So yes, our first option was having a branching workflow where we would create a branch for every new story or feature, and the changes would get merged to master or a release branch if that's the direction we decided to go, only after they were completed. And this would ensure that no half-baked goes into master, because you're very conscious about what's getting merged into master. Now, this of course is clearly it's a technique that works. It's something that people use all the time. But in my opinion, there are a few problems with it. So if you look at this diagram that you have here, it might look familiar to what you've been doing sometime. You have a master which has different versions of, you can call, if you're using Git, you can call them tags, you can call them release versions, you can call them anything you want. But let's start with v0.1, which was your first release. From there, you pulled a develop branch, which is the one that you're constantly making changes to. From the develop branch, your developers would pull their feature branches, make changes on those feature branches, merge it back to the develop branch, which would then go back to a release branch. Now, let's say your version 0.1 had a bug, so you need to release a hotfix. So you'd pull a hotfix branch, make the hotfix, push it back to master. But at the same time, you have to make sure that your hotfix also goes into your develop branch, which also means it has to go into your feature branch and each of the different feature branches that you have. And again, this can go on for a while, right? You discover a bug, you push it to master, but then again, you have to rebase or merge all of your existing branches. Then you don't know if that causes merge conflicts. You spend time fixing that. There's a lot of things that happen. But again, I'm in no way saying that this is wrong or anything. It's an approach that works. And, but like I said, there are a few issues with it, right? So there is constant merging across branches because you want to avoid conflicts, especially if you're constantly merging back to a common branch. You have to keep pulling changes onto your branch to avoid long-running conflicts. And because you're doing feature branching, your branches can be pretty long-running, which could also lead to merge conflicts. It's difficult to reuse code because people are working in isolation, the branches are in isolation, so that you end up creating a lot of duplication across branches, and that in turn leads to, well, it affects the quality because you're mostly, from what I have seen at least, people tend to not refactor very frequently. It's like, okay, we'll take care of it later. We need to finish the features first. And that results in what is commonly known as a broken window problem, right? That if a house has broken windows, then it gives other people or vandals, the freedom to go and break more windows. Well, it's already broken, who cares anymore? And it's the same with code. If there's already code in there which is not the best quality, maybe not well tested, maybe there's a lot of duplication, then a lot of the times the tendency is to, one more duplicated method will not really affect anything. But that's not entirely true, because in the long run that doesn't help. And given that developers are working in isolation and features are being developed in isolation, it becomes difficult to test code in a non-production environment. So to give you an example of my current client, there are multiple squads that they have, and each squad is working on a different part of a mobile application and a backend system, which connects to a backend system. And they have a dev environment, an SIT environment, and a UAT, which we don't really have access to. On the dev environment, the idea is for developers to be able to test features quickly and get faster feedback on what they've been developing. But there are no pipelines to deploy to dev. So what people do is build a war locally and copy it over into the dev server, which means that if I wanted to test my feature that I'm developing locally, and Purnima wanted to test her feature that she's developing locally, at some point we're going to be like, okay, wait, that's not what I did. Where are my changes? What happened? Right? So it becomes difficult when you're trying to develop things in isolation. Does everyone agree with that? Or am I just talking bullshit right now? Okay, I see nods. So, no, you don't agree? Of course, none of what I'm saying applies in all scenarios, right? I'm taking a very generalized view of things, and it is largely based on my own experience. Your experience can be completely different, and that's fine. Okay, so our option 2 was trunk-based development, which personally I'm a big fan of. And hopefully I'll be able to convince you that it's not the worst thing in the world. To quote a definition from Toptal, at least I think that's how it's said, in the world of software development, a trunk means the main development branch under a version control system. It's the base of a project where all improvements are being merged together. So to break that down into what has been my experience is you have a master branch. Every person works on the master branch. You make commits to the master branch. You test things locally. You run your builds locally before you push to master. And you only push to master if your tests are green and if everything works as you expect. So has anyone here had any experience with trunk-based development? Michael has, one more person. Have you heard of the term trunk-based development? Okay, cool, okay. I mean before today, right? Yeah, okay. So let's talk about trunk-based development a little bit more. Like I said, all code gets merged into a single trunk branch. It could be master, it could be a different trunk that you want to use depending on your use case. Trunk-based development does not mean that you can't have branches, but the idea is to always have short-lived branches. You want to quickly do a spike on something, you want to check how something works, you pull out a branch, make your changes, either merge it back to master or delete that branch once you're done. The idea is to ensure that you always have a single source of truth for your code, which means that at no point do I have to wonder if there is something else happening in parallel. I know whatever's in my master is the one I'm going to use, and if there is somebody who's been doing something in isolation, then they have to sort of merge back to master and go from there as opposed to the other way around, which normally ends up happening when you're doing feature branching. And because now you have a single source of truth and because everybody is merging to the same branch, what it results in that you can have easy reusability of code across features. If you're doing a refactoring, that gets applied to everybody at all times. You're writing new tests, that gets covered for everybody. And you're not stepping on each other's toes because you're all on the same branch and you're all pushing to the same branch. Any questions about trunk-based development just based on that? I will talk more about it. Okay, cool. Now, of course, as with everything else, trunk-based development also has its downsides. So if the trunk is broken, it means that everybody else is potentially blocked from committing. So normally on teams which do follow trunk-based development, if let's say the build is broken, then the priority for the whole team is always to fix the build and not to continue working. It also means that you have to always have a very good coverage of tests because you're always merging to a branch that everybody else is using. You want to make sure that it's at least up and running and everything functions at any given point of time. So there is an extra effort involved in making sure you have multiple layers of testing. You want your unit test in there, you want your integration tests in there, you want your end-to-end tests in there, and you want to guard against any potential issues. And like we said earlier, because the issue is work in progress code, that is something that you have to take care of even when you're doing trunk-based development, because we're talking about having smaller commits, because we're talking about short-lived branches, because we're talking about always committing to master. There is, of course, we're running the risk of pushing half-baked code if we're not completely careful about it. So now to my favorite topic, feature toggles. That is the one way I have personally used on a lot of my teams, and it has worked for us when it comes to using trunk-based development while also ensuring that work in progress features are hidden and not, what's the word I'm looking for, are not deployed to production or a higher environment if we don't wish it to. Have people heard of feature toggles before? Can you get a quick show of hands? Oh, okay, cool. How many people have used feature toggles? Okay, quite a few. That's good. So this isn't exactly new what I'm talking about. So feature toggles, as Pete Hudson says on the ThoughtWorks blog, feature toggles are referred to as feature flags, are a powerful technique allowing teams to modify system behavior without changing code. So as the name suggests, it's a switch that allows you to toggle your features on and off as per your requirement. There are multiple ways of doing it. I have put together a short demo, which I'm going to show in a bit. But the idea is to, instead of pulling out branches, instead of isolating the work, we still keep the work, but we hide it in plain sight, for lack of a better analogy. You're hiding it in plain sight by just toggling it off, or by hiding the entry point. You can use environment variables, which is what I'm going to use in my demo later. And then you are still using all the upsides of trunk-based development, and you're avoiding some of the downsides of feature branching by not isolating code and by allowing easy reusability. So you can separate your development concerns from your deployment concerns. You have the ability to turn features on and off in different environments selectively, and it lets you test work-in-progress features across environments. So to give you an example, and I don't have the diagram that I thought I did. So to give you an example, let's say you have your CI pipeline where you're building, running tests, integrating, and then that deploys to environments. You have multiple environments. You have your dev environment, you have your QA environment, let's say you have a pre-production staging environment, and then you have your production environment. Now, given that my feature toggles are almost always configuration based, and your configuration will be different across environments, I could choose to have a feature on in, say, dev and QA, but off in staging and production. So which means I can still test that feature in my dev environment, in my QA environment, and once I'm happy with it, all I need to do is turn the toggle on in staging and eventually in production, as opposed to having to figure out how the deployment goes, do all the permutation and combination to figure out whether or not this feature is ready. And that's exactly what allows you the ability to actually test in production. If you did want to test in production, it's a little bit like A/B testing, right? You can have your feature toggle on for some users and not on for others. And that way you're not having to constantly deploy and redeploy. You can just have it, the feature is always there, just the availability is what's configurable. It also, if you're building mobile apps, for example, right, and you don't want a certain feature available to your users yet, then normally what you would do is to turn that feature on, you need to release the app again, which anybody who's worked with mobile apps knows that is not exactly a straightforward process, especially with Apple Store, right? So, App Store, not Apple Store, the App Store. So, if you're using feature toggles, what you can do is your feature, you can release it with your major app release, and then you can provide an ability to turn the feature toggle back on or off from the backend. And then it's your backend configuration, you switch it on, your features available to your users. We did that recently for another client where you had a tile on their dashboard. We pushed the tile the entire time, but the toggling on was managed from an admin portal in the backend. So you didn't need an app release to turn it on. And because the tile led to a web view, it also meant that even if there were changes to the actual implementation of what was happening on the tile, then that could still be controlled because it was deployed in S3 or something, which is a static web page. So moving on, the whole point of me talking about trunk-based development and feature toggles is because they aid in continuous deployment and continuous delivery. Now, given you people have heard of trunk-based development and feature toggles, I'm going to assume that you know what CD is. But I'll still talk about it. So continuous delivery versus continuous deployment, of course, there's a lot of confusion around these terms. Continuous delivery is the practice by which every commit that passes through the pipelines is deployable to production. It doesn't mean that every commit goes to production. What it means is it could if you so chose to. If today I triggered my production pipeline, then I know that everything is ready and everything's going to work fine because my pipeline and my trunk is built that way. Versus continuous deployment, where the practice is that every commit that passes through the pipeline is deployed to production. So completely no manual intervention, no clicking of buttons, no hand rolling of production deployments. Everything gets pushed to production the moment it passes your tests. Now again, as I said earlier, what you really need for practicing something like CD, both continuous delivery and continuous deployment, is to have a near 100% test coverage. I won't say 100% because in my opinion, and I'm sure a few of my colleagues will agree, 100% test coverage is a bit of a fallacy. It's almost impossible to have 100% test coverage while also writing meaningful tests. So yeah, if you see 100% test coverage somewhere, you should be a little careful. So if you have faith in your tests and if you know that you have your test coverage in place, then continuous deployment and continuous delivery really isn't that, it's not rocket science really. Let's take an example of something I was talking about earlier, right? So you have your source code, which is, let's say, your different services that you have. That you build your source code. I should also point out that I've just completely stolen this off a ThoughtWorks blog. I'm allowed to do that, they're my ex-employer. So you have your source code, you build it, you have other things that go in. You could have your unit tests, you could have your integration tests, you have your functional test, you could, if you so chose, you could have built-in load testing and performance testing in your pipelines. And once all of that is done, it gets packaged. It goes, there's your, I'm assuming integration means integration tests here, your different end-to-end tests across different services, which then goes into test environments. And you see there's this little env and app config thing over there, which is essentially what controls things like your feature toggles and different configurations across environments. So given that you have a centralized config, or it doesn't even have to be centralized, depending on, again, what your use case is. But given each test environment has its own config in some way or the other, it becomes very easy for you to, for example, toggle features on and off or have different configurations across your environments. And once all of that is done, once you're ready to deploy all of this, it goes into staging, and after that production is a manual step. So that's the continuous delivery approach, where everything up until production is automated, but just the deployment to production is a single button. The other similar approach is continuous deployment, where the only difference is that your deployment to production is automated. Once you've run you can have smoke tests or something running in staging, and once it's ready, it deploys to production automatically. Now, you might then say, oh, but if everything gets deployed to production and you're deploying, if you're committing 50 times a day, that means you're doing 50 production deployments a day. And that's true. Yes, you are doing 50 production deployments a day. And there are strategies, and a lot has been written about those, to how to avoid things like system downtime, for example. So if you're interested, later we can talk about things like blue-green deployments or canary deployments. And that allows you to actually deploy to production 50 times a day if that's something that works for you. And again, what I'm saying is a very generalized thing. It may not apply to everybody. There are, of course, systems where continuous deployment and continuous delivery may not be realistic. But given most of my experience has been with web apps and end-to-end customer-facing applications, this is something that has always worked for us. Do I have anything more? I do. So why should you do CD? Well, it enforces better quality code because you're constantly, because you're using a single source of truth, because you're constantly pushing to the same branches, all your developers are pushing to the same branches, because you have high levels of code coverage and you're running tests all the time, and every single commit does run those tests, and you're able to test across different environments in different scenarios. At the end of the day, it all boils down to having better quality code across your environments. It enables faster feedback. There is no more manual intervention for deployments, and because there is no more manual intervention for deployments, and because your deployments are now a very run-of-the-mill sort of an activity, there are no more sleepless nights. Because you don't have to worry about, oh, we have a deployment coming up, 10 p.m. to 6 a.m. is the only slot we have, you can't have system downtime, and there's a whole lot of things. Now this is, it just makes it super easy and super convenient to just deploy to production whenever you want. And that was all the talking that I had to do. I have a little demo planned, but before I go on, are there any questions, comments? I still have time, right? Okay. Wow, okay. Yes?
Hi. So For the feature control, you said that to save it in the config DB, right?
It depends. So there are multiple things. So for example, if you're using Java, Java has something called a feature toggles. It's like a library or a framework, which you can integrate in your Java code and use it. You could save it in a database. What I have used in the past is we save it in environment variables so that it's easier to again switch it across environments. So it doesn't necessarily have to be a database. It's completely up to you and completely up to the team to decide how they want to do feature toggles. We've even done something where it was being controlled by query params on your web page. So if you had a query param that says, oh, one that we had was a holiday management feature that actually gave us a lot of trouble. So if you have, let's say, a query param saying feature holiday management equals true, then you will have that feature available on your web page. If not, then you won't. So does that answer your question?
Yeah, just wondering what is the best way, because I'm thinking like if we are using a DB and we have some core feature that, let's say our call to DB fails somehow, and then the feature control got turned off, and then it might affecting the production environment.
Right. Yes, that is a likely thing to happen, right? But then if your DB is gone down or if your DB calls are failing, then maybe the feature toggle is not your biggest problem over there. But at the same time, normally what you would do is by default your feature toggles are turned off, and you turn them on very deliberately. So yes, there is a possibility that if you're saving this config in a DB, then you might end up in a situation where the call fails and then you don't know what the value of the feature toggle is. But in that case, by default, it will be turned off. And of course, you would know because you're constantly running tests, right? The next commit would tell you, oh, something failed over here, and then you would know that your feature toggle is broken.
And one last thing.
Yeah.
How often you usually clear your feature control, or you just leave it there, or after some time you will?
Right. So, that's a very good question. I think I meant to cover that during this. But the idea for feature toggles is that they should be short-lived always. You can't say, oh, this feature toggle has been there for the last 6 months. Because if you've had a feature toggle that's been there for 6 months, it means that there's something wrong either with the way you're delivering this feature, or there's something wrong with the initial requirement that you were trying to fulfill with this feature. I can't give you a timeline on how long a feature toggle should live, but the idea is as soon as you develop a feature, you've tested it and you're ready to deploy it to production, you get rid of your feature toggle then. Cool. Sorry, I didn't catch that. Absolutely, you can. If you want, you can say you can set a certain limit saying if this feature toggle has been there for longer than, I don't know, depending on your feature, let's say 1 month, right? You can say if the life cycle of this feature toggle is longer than 1 month, then you either send out an alert, you fail your build, you can, if you're feeling particularly adventurous, delete it automatically. I won't suggest doing that, but it's an option. So yeah, thanks Dave. All right, cool. Okay, so if there's nothing else, let me see if I can share my demo. All right, so what I have here is something very, very simplistic. I have a page here that says, welcome to Voxxed Days SG 2019. And if you see, I have a feature 1 toggle and a feature 2 toggle, which both say false. Actually, let me do it there. Yeah. Is that, can you even see? Yes, okay, cool. So you see I have a feature 1 toggle false, feature 2 toggle false. What I also have is a hidden route called /feature toggles. Normally if this is something you're building into your web apps, it is strongly recommended to have this password protected because, well, for obvious reasons, if someone discovers that you have a hidden route called /feature toggles, and they could completely mess up your system and probably hamper something like your marketing if you were planning something big, right? So yeah, you could have something like this where what I have is again something very simplistic, and I lost it. Oh, there. Where I have 2 checkboxes for my feature 1 and feature 2. By default, they're false, so the checkboxes are not checked. If I, let's say, check feature 1 and update, once I go back and refresh my original page, you see that thing came up, which is this is shown if feature 1 is on, and I can do the same with feature 2. And if I refresh this, I now have another feature which is only shown if the toggle for feature 2 is on. So what I have done is very straightforward in here, which is I have an in-memory JavaScript object which has values for feature 1 and feature 2. When I select the checkbox and I say update, that value changes, and then I come back here and I check that value and I show a certain section of my application only if the toggle is on. So again, it's a good way to make sure that things don't go into production. Right now, of course, I don't have multiple environments, so I'm not doing this. There's no selective way of doing it, but if you were using this across different environments, your config would live in some place that was more conducive to that particular environment. So for example, if you see, I have this C API version over here. When I click on this, it goes to another route which says the API version is undefined. Now the reason this is undefined is because, let me try and do this. I'm basing it on a feature on a environment variable called feature version, which if you see right now, the value is undefined, it's empty. So my front end doesn't know what the value is. Now let's say I decided to set a value here, which I'll say v1, and I start my server again. When I go back and take a look here, you see now it says the current API version is v1. Now for this, I could now, because it's an environment variable, each of my different environments could have a different value for this environment variable, and I could put in a check in my code based on that environment variable, which would then let me do things with it. Now there are ways of doing it. You could give it a specific value like I did, like v1 or v2 based on what you were using. You could give it true or false. So you have Boolean checks in your services. It's completely up to you how you want to use them, but the idea is to, one, make them configurable across your environments, and two, make sure that they are short-lived so that you're not running into the same problem that you do with, let's say, long-running feature branches where something's been there for so long and now it's just basically stale. Yeah, so that was my sweet little demo that I had put together. I've written it using Node and some Express.js and Jade. None of which I know very well. Oh, Jade is now called Pug, apparently. Yeah, so that was it. Thank you very much. Oh no, that's not where I want to go. Here. Yes, thank you very much. That's my email address in case you want to talk or just chat, or if you have any questions and feedback, I'd highly appreciate it. Thank you very much.